Hi everyone! In this video I'll be talking about trig graphs, the basic introduction to sine and cos graphs which you need to complete exercise 10. For the past few weeks we've been looking at trig and we've been looking at the following two scenarios. Either we have a triangle where we're trying to find unknown sides, for example we're trying to find the opposite length, or we're trying to find this angle in there, and we use trig to solve those. Or otherwise we have a triangle again but in the Cartesian plane, and then we're trying to find the unknown y value, the unknown x value, and these are very useful applications of trig. Engineers, quantity surveyors, they all use it to calculate, okay, what is the distance I need, what's the angle I need for this roof, all very useful. Another use for trig is in functions. So written here below we have y equals sine theta and y equals cos theta. Okay, so this looks a little bit alien at first, but when you start looking at it, it looks exactly the same actually as a function that you might know, such as y equals x. Okay, so y equals x can be plotted on the Cartesian plane. Okay, we've got our y and our x, and if we plot the y equals x on the Cartesian plane, we get something like that. Okay, so in today's lesson, we're going to learn how to plot trigonometric functions. We're going to start with the y equals sine theta function and the y equals cos theta function. There are a few important things that we need to know before we can start plotting trig functions. So trig functions generally have wave shapes, such as the one shown below. They plotted on the Cartesian plane. There's a little bit of a mix-up because we've got y on the y-axis as usual, but on the x-axis we have theta values, which is in degrees. So we have 90 degrees, 180 degrees, as you can see. And there's a few key components of graphs in general that we need to know before we can start doing these sketches and interpretations, which is why I'm going to jump into a quick crash course on graphs. The first two components we can read off of a graph are the domain and the range. Okay, so the domain is the set of possible theta values. This is usually given to you in your question. For example, it's going to tell you plot the graph of y equals sine theta between theta equals 0 and theta equals 360. So that's your domain. It's all the possible values of theta. So in this case, we have theta ranging from 0 over here and 360 over here. It touches those points, so it's included. And so we have our domain is x is an element of 0 degrees and 360 degrees. The range is the same thing, except in this case, it's for the y values. So it's a set of possible y values. In this case, we have the y values ranging from 1 to -1. So once again, it's included. So our range is simply -1 to 1. And that's, you can also say y is an element of that. So that's pretty simple. The domain and range, those are the first two components we need for these graphs. The next two components we can read from a graph such as this are the x-intercepts and the y-intercepts. This is the same as usual, it's the same as you always do in the Cartesian plane. You simply read off the points where the graph intercepts the x-axis and the y-axis, or the theta-axis and the y-axis in this case. So for the x-intercepts, we can see it intercepts here at the 0 point, it intercepts again at the 180 degree point, and again at the 360 degree point. So I don't want to waste the time writing these all down. But for example, we're going to have 0, 0, and then we're going to have at the point 180 degrees and 0 and 360 degrees 0. Okay, the y-intercept is the same as usual. It's where does it intercept the y-axis, and in this case it only intercepts the y-axis at the point 0, 0. The next two components that we can read from these graphs are the max value and the min value. Of course, this is pretty self-explanatory. In some cases, the textbooks also call it the maximum turning points or the minimum turning points. Basically, the maximum value is the highest point on the graph, which in this case we see is up here, which is 1. The minimum value is the lowest point on the graph, so that's here, that's at -1. And so we simply write our max value as y equals 1, and our minimum value as y equals -1. The last two components we need for now are the amplitude and the period. So you may have come across these terms in science when you studied wave theory, for example. If you haven't, don't worry, we're going to go through them a lot now as well. So the amplitude is defined as the height between the x-axis and the maximum value. In other words, it's this here. So it stretches from the x-axis to the maximum value. It's the same as this one here, from the x-axis to the minimum value. It's that height. So in this case, it stretches from 0 to 1, or 0 to -1. So the height is going to be 1. It's a distance of 1. So our amplitude is equal to 1. Okay, we always take the positive value for amplitude. Our period is the number of degrees needed to complete a wave. Okay, what that means is that it is the number of degrees between the start of the wave here and the finish of the wave here. Okay, so a complete wave is defined as a crest and a trough. So we've got our crest up here and our trough down here. Okay, so our period stretches from 0 all the way to 360 degrees. So that's our period. Okay, so that means our period is 360 degrees. That's how many degrees are needed to complete this wave. Now that we have these basics in place, we can start looking at how to draw and interpret the basic trig graphs. I'm going to start by looking at y equals sine theta. The first thing we can notice is that we are given the domain for theta. So we're supposed to draw this graph between 0 and 360 degrees. It's a little bit confusing to know where to start because it's a different kind of graph, so we don't really know the shape yet. So what I usually do is I start with the table as shown below. And you basically just plug in a few theta points into that y equals sine theta equation. So if we plug in 0, we get y equals sine 0, and that answer is 0. Oh, sorry, not degrees. If we plug in 90 degrees, we get 1. If you plug in y equals sine 180, we get 0 again. Y equals sine 270, we get -1. And y equals sine 360, we get 0. So you can do that on your calculator. Just make sure your calculator is in degrees and not radians. Then we use these points and we plot them on the graph above. So we have a point here at 0, we have one at 90, 180, 270, and 360. And now you want to fill these points, connect them with a line, but make sure that it is a smooth curve and not straight lines, because it is supposed to be a wave shape. Okay, there we go. So that's the shape for the sine graph. Now that we've drawn the sine graph, we can start answering some of the interpretation questions. Honestly, I think this is the easiest part because you're just reading off of the graph. So if we start with range, the range, as we know, is the possible y values. So as before, we can see it ranges from 1 to -1. So that's our range. Okay, and you can say that y is an element of that. Okay, for the domain, it's all the possible theta values. As I said, it's given in the question actually, so it's theta is an element of 0 to 360. Okay, now we're getting to the max and min. So the max is the maximum y value we can get. We can see from this one the max that we can get is actually 1. So our max is y equals 1. Our minimum, again, is y equals -1, as that's the smallest y value we get. And then the amplitude and the period. So as we said, the amplitude is always this length here from the 0 to the maximum value. So once again, we see that that's actually 1. And the period is from the start of the wave here all the way to the end of the wave here. And again, it's 360 degrees. Okay, so amplitude we had 1, period is 360 degrees. Okay, so that's how you do the drawing and interpretation of the sine graph. The next basic graph we're going to look at is the cos graph. Again, we're looking at it between the values of theta equals 0 and theta equals 360. So I'm sure you're getting the hang of it already, so I filled in some of the values. So the first step, as always, we need to plot the points. To do that, we need the points. So I've substituted different values of theta into y equals cos theta to get the values in the table. Okay, so we can start by plotting these points. So we have cos theta, when theta is equal to 0, we've got y1, then 0, -1, 0, so again, we draw our graph. Remember to use curves because it's supposed to be a wave. Okay, so that's how the cos graph looks. Obviously, it's going to keep going on here, and it would keep going on there, but we only need to draw it up till there and up till there for the sake of this domain. Okay, so let's type that away. So what we can do now is we can start moving on to the interpretation questions. So the range we're going to see is the same. So it's between -1 and 1, so that's the same as for the sine. The domain, again, is the same between 0 and 360. The max and the min, also, the max is 1, the min is -1. So let's just fill this in. So 0, 360. So that's 1, y equals 1. Y equals -1. The amplitude, again, we draw it from the, let's say we draw it from 0 to the lowest point or 0 to the highest point. Either way, that distance there, this distance here, is 1, so our amplitude is still 1. And the period is from, in this case we don't have a full crest and a full trough, but what we've got here is we've got the start of the crest here and the end of another crest here, so that actually equals 1 full crest, and we've got 1 full trough at the bottom here, so the period can still be calculated using that, and that is 360 degrees. So that's how we do the cos graph. If you have any questions on that so far, please feel free to ask me in the comments or ask me on Teams, email me, you know where to reach me. I'll be doing some more complicated questions in the next videos.